Good morning everybody. Let us continue with our section on double integrals and polar coordinates. So we have seen in this chapter that or in this section that it is pretty much easy to calculate the double integral or the area or volume of any given region much more easier with the help of polar coordinates once we get to know or once we are able to transform the limits which are given in Cartesian coordinates into polar coordinates. So for most of the integrals are very much easy to solve. So let us in this lecture let's just give or discuss about an example which is given in your textbook regarding the determination of the volume of a given region. So let's see example 3. We are asked to find the volume of a solid that is under the hemisphere z is equal to root of 1 minus x square minus y square and above the region bounded by the graph of the circles x square plus y square minus y is equal to 0. So the figure 9.11.5 depicts the region actually. That is, we need to find the volume that is under the hemisphere and above the region which is bounded by the graph of the circle x square plus y square minus y equal to 0. So if you see this portion, this is the circle x square plus y square minus y is equal to 0. Okay, and the hemisphere is the blue region. Z is equal to root of 1 minus x square minus y square. So if we just extend this part, we actually need to find the volume of this particular region. That is, the region is bounded by the graph of x square plus y square minus y. It is bounded by the graph of the circle and it is under the hemisphere. So let's see how we can convert the equation into polar form. So first of all, what is given? We are given z is equal to root of 1 minus x square minus y square, that is f of xy, that is given to us. So if we convert that into polar form, x square minus y square will be replaced by r square. Okay, now we need to find the limits, right? How can we find the limits? Here we'll have this circular region, whole of the circular region, right? So here theta will be varying from 0 to 2 pi, and we'll have we have obtained the variation of theta. Now we'll have the variation of r. How to determine the variation of r? It will be entering at 0. If you just draw a ray like this, it will be entering at the point 0, r is equal to 0, and exiting at this portion, that is the bounded by the graph. The region is bounded by the circle x square plus y square minus y is equal to 0, right? So what we do is, in this equation, from this, with the help of this equation, we are going to find the value of r, because if we allow a ray to pass like this, it will be entering at 0 and leaving at the surface which is bounded by this circle. So if we put x is equal to r cos theta, y is equal to r sin theta, and again y is equal to r sin theta equal to 0, from this we get r square minus r sin theta equal to 0, that is r is equal to sin theta. So that is how we can find the limit of r. Okay, so the limit of theta is simple, that is we'll have to consider whole of the circle, and to find the limits of r we have to see or just pass a ray or a line which passes through the region. So see where it enters and where it should exit. So here it will be from 0, r is equal to 0 to, it will be passing out through the surface which is bounded by this given circle. So we'll have to find the value of r with the help of this given circle. So with the help of that we get r is equal to sin theta. Now let's move on to the integration part. It's pretty much simple. So here we are using 2 times of, instead of using 0 to 2 pi wholly, we are using 2 times of 0 to pi by 2, that is half of it. So the volume will be nothing but double integral over r root of f of xy. F of xy is nothing but z, that is root of 1 minus r square into dA, that is nothing but 2 times integral 0 to pi by 2 integral 0 to sin theta 1 minus r square whole raised to 1 by 2, it is root of 1 minus r square itself, into dA will be replaced by r into dr into d theta. So again reminding you, don't forget this r over here. So let's see how we can evaluate. I think it's easy. We can just substitute the value 1 minus r square is equal to u. So when we substituted, this r will get cancelled. So it will be the valuation of u raised to 1 by 2. What is the integration of u raised to 1 by 2? It is nothing but u raised to 3 by 2 whole by 3 by 2. So when we substitute it, we get it is 2 times 0 to pi by 2 integral minus 1 by 3 1 minus r square whole raised to 3 by 2. Okay, the 2 and 2 will get cancelled. If you substitute 1 minus r square is equal to u, we'll have minus 2r dr is equal to du, right? So du will be nothing but, dr will be nothing but du by 2r. So r will get cancelled and there will be 2 remaining, and the integration of u raised to 1 by 2 is u raised to 3 by 2 by 3 by 2. So the 2 and 2 will get cancelled. So here let's see, it will be minus 1 by 3 1 minus r square whole raised to 3 by 2 varying from 0 to sine theta. Okay, so when we substitute the value of sine theta, it will be I'm taking this 3 common, it will be minus of 1 minus sine square theta whole raised to 3 by 2, and when we put 0 it will become 1 raised to 3 by 2, that is 1. So the integration will be value will be 1 minus sine square theta whole raised to 3 by 2. And what is 1 minus sine square theta? That is cos square theta. So 1 minus cos square theta whole raised to 3 by 2. So removing, cancelling out the powers, we will get 1 minus cos cube theta. Now how can we simplify this cos cube theta? That is, how can we integrate this? The integration of 1 is simple, it is theta itself. Now to integrate cos cube theta, what we are going to do is, I'm going to take cos square theta out common and one remaining cos theta, that is cos square theta into cos theta. And what is cos square theta? It is 1 minus sine square theta. So it will be 1 minus sine square theta into cos theta. Okay, now let's just expand this bracket. It will be 1 minus cos theta into sine square theta. Now the integration of 1 is theta, integration of minus cos theta is minus sine theta. And what will happen to sine square theta into cos theta? Here again we'll substitute, right? Put u is equal to sine theta, then what will be du? Cos theta. So cos theta into d theta. So cos theta will get cancelled and we'll have to integrate u square, that is u cube by 3. So that's how you have got 1 by 3 into sine cube theta, and the variation of theta is from 0 to pi by 2. So when we substitute this value, we'll get the answer to be pi by 3 minus 4 by 9. So the same problem, if you are asked to find the area, we just have to put double integral into dA. That is, we don't need any f of x, y, z or the value of z. Okay, so f of r theta is equal to 1. That will give the value of our area of the given region. So this is how we can determine the volume of the any given region. That is, we'll have to consider the region which is given to us, and from the given z, we have to consider a z value which is given to us, and that will be our function. And then we'll have to determine the limits of our theta and r and do accordingly. So with this, we shall wind up today's session. Thank you. Stay home and stay safe.